Yeah, no, 100%.
Things I say.
100%. Yeah.
He's probably sitting over there when you're sitting there.
It probably is.
Running late and he didn't file a little paper.
You recycled it.
All right, that'll do.
Talking off the top of my head is not. That's why I don't hear about it.
Felt like it went great.
Yeah, no, I think that's good. I got a lot of feedback from people like yours too. That, like,
Lily's going
like,
first.
honestly,
Yes.
they're really
I'll take care of that.
see if people can want to do it.
Yeah. Yeah, I was curious how many people would come. Because given the big room and the repeat session, is quite a lot of people that can come.
Yeah.
That can come.
Well, at the end of the day, the live sessions is kind of hit or miss too, because sometimes people go home.
Well, I was telling Sherry, I don't know how many people you noticed, but there were a few people who were watching with their like mouth open, like kind of staring at the ceiling. There
Yeah.
were a few people totally zoned out. I was just like, I could see you.
Well, yeah, it's 8:30 in the morning. They're probably like asleep still.
Yeah.
All right, let's make sure this thing works. No, it does not.
Wait, we only have an hour.
Yes. Yeah, no question.
Alright, Laura wants to go home anyway.
No one wants to, yeah.
Is there like an on it?
I'm going to move it once.
Like turn it is it? Can I turn it back on? Oh, it's vibrating.
I moved it. You didn't move it. I moved it. But like, is it just need to sync with it?
Oh.
There you go. Nice. Yes.
That was annoying. There were a few times when I missed clicking. Only up there.
Mike's sitting.
All right. If everybody could take their seats, we're going to get started here in just a minute. All right, I want to get you guys started, or get these guys started so that everyone can get out on time. This morning we had an hour and 15 minutes. Today right now we only have an hour, so less questions. Maybe they'll move faster. I'm not sure. But I'm Sherry Calhoun, and I'm working roadway design on the research, standards, and innovation team. And we're going to start out this this roundabout topic with Lily Cloud and Ty Smith, and at the end we'll hear a little bit from Mike Lindgren. That'll be the first part. So, Lily, you want to start out? No, Ty, we want to start out. Sorry, got it backwards.
You're all good. All right. Well, hopefully we can answer some questions and give some whys about some of the changes that we have made for roundabouts. So to go ahead and get started, I'll give you a brief history.
Can you hear back there?
Can you hear me, guys?
Can't hear you up front.
Testing.
I
Is
think
there-
part of that was the people outside.
Hello, hello. I'll just get nice and comfortable with it. Okay, so I'll give you guys a brief history of roundabout guidance in the state of North Carolina. So it started out with NCHRP Report 672. That came out in 2010. We added a link to that, and that was essentially all of the roundabout guidance we did at that time. Then NCHRP Report 1043 came out. That was early 2023. And then in November of 2023, we added a link to that, as well as a little bit of tailored guidance for North Carolina. And then finally, that brings us to February of this year, where we have created our roundabout update. So the reason for this update is because we have had enough roundabouts in the state that we have faced a couple of reoccurring challenges. And so we've taken some lessons learned from those projects. We've also taken national guidance as well as guidance from some other states, Florida being one of them. And so we've compiled all of that information into this update. So what was actually added? We've added to 2 sections. The first section is going to be an overview of roundabouts, and the second section is going to get into the design of roundabouts. So for the first section, for our overview, that is in 8.2, which is the types of intersections, and there are going to be 4 types of roundabouts that we discuss in that section. The first one is going to be single-lane roundabouts. That is the default roundabout you should consider. We then have mini roundabouts. A mini roundabout is going to be a little bit smaller, and they're generally an upgrade from a 4-way stop. And then we have multi-lane roundabouts. NCDOT is recommending 2x1 for our multi-lane roundabouts. You can do a 2x2 if you talk to congestion management, but we are highly discouraging it due to some of the issues we have had with them in the past. Finally, we have modular roundabouts. Modular roundabouts are quick and easy to put up. They're very cheap. However, we have some concerns with the length of time that they will function. So to get into 8.10, that is our design guidance. This section is going to be orienting designers. It is not going to be a one-stop shop. You are still going to use the NCHRP report, but this is going to give you an understanding of what we are looking for in North Carolina. The main thing it talks about is the roundabout design process. The way that this works is that roundabouts are very versatile, and so you as a designer need to keep your objective for this location in mind. Some objectives you can see here we have listed: speed control, pedestrian and bicycle accommodations, large design vehicles, high capacity, and right-of-way impacts. What we want you to do is think about your project location, think about your scope, think about your stakeholders, think about what is important in that location. Pick the most important thing, and when you are designing your roundabout, keep that in mind. Roundabouts can be optimized, but generally when you make a change, it will give you pros in one side and you will have losses in the other side. We want to make sure that we are considering our objective when we are weighing those two. There are 2 stages that we discuss in this update. The first one is initial design. Initial design is not a part of the PDN, as you may know. The reason we chose initial design is because this could happen at a number of different points. If you have a feasibility study that happens with your project, initial design would happen at that stage. If you do not have something like that, then initial design would be essentially the first half of DRPS. During initial design, you need to consider these 6 things. The first thing to consider is your alignments. You need to create horizontal and vertical alignments, as well as set the size and location of your roundabout circle. The location of your roundabout circle is something we want to emphasize. This is something that you should be intentional with. A lot of designers will put the center of their circle at the crossroads of their alignments, and we want to emphasize that if you move the location of that roundabout, you can get gains on some of your approach angles. Speaking of approach angles, for leg design, you have approach legs and departure legs. For approach legs, our focus is slowing people down to the operating speed of the roundabout. So as you can see here on that right side leg, that is showing slowly decreasing radius curves. Then for the design of departure legs. For a departure leg, we want to make sure that we are allowing people to accelerate out of our roundabouts. Another thing that goes hand in hand with those 2 things is going to be truck aprons. We're talking about external truck aprons here, and essentially we want to limit them for 2 reasons. The first is a pedestrian issue, which we will talk about later in the presentation, but they are also a large chunk of the cost for roundabouts. The final layout thing that you will think about here is going to be your bypass lanes. Once you have your entire layout done, we can look at our fastest path calculations. For anybody who doesn't know what a fastest path calculation is, it is essentially the theoretical speed that you could travel through the roundabout. We want to make sure that all of these paths are similar in speed, but that's something Lily will get into a little bit more later on in the presentation. The final thing to consider here is going to be driveways. We are fine with commercial driveways attaching to roundabouts, but they need to be designed as a leg of the roundabout. So that means that anything you would consider with a street connecting to a roundabout, you need to think about those same things with a commercial driveway. We are also, in general, limiting residential driveways attaching to roundabouts. The second and final stage that we talk about is going to be DRPS. And if you look at this section, there are a lot of bullet points, and what you will see is a lot of things that say revise, confirm, and review. Essentially, this stage is iterating through previous designs. So nobody's going to get a roundabout perfect on their first try. We want to emphasize that. You are going to have to make a lot of changes, a lot of adjustments, look at previous things, see what you can do, what changes can be made to improve your roundabout. There are two other things we're going to add at this stage. We're going to add sight distance calculations, and that's going to be intersection as well as stopping sight. And then we're going to add island details. So now we're going to talk a little bit about the typical section changes we have made. So the thing I want to be very clear about on this slide is that this is a typical section. This is not a standard. We do not want to see 12, 18, and 10 used for all roundabouts. This is us sharing kind of a starting point, but you should always get guidance and get actual backup for the numbers that you are using on your projects. The things that I want to highlight here is going to be changes to the truck apron, which is that A1, changes to rolled curb, which is R2, and then changes to our pavement schedule, as well as changes to R3, which is our modified 2'6" curb and gutter. 2'6" curb and gutter is the standard for roundabouts. We want to recommend it on all of them. We believe that curb and gutter has inherent speed control when compared to shoulder and pavement markings. Essentially, that vertical face of the curb is a much better enforcer than a line is. You do not, however, have to run curb and gutter over your entire project. It just can be limited to the roundabout. The first typical section change we're going to talk about is the thickness of concrete truck aprons. That has been in the past anywhere from 7 to 12 inches, and we're using 12 inches as a standard moving forward. There have been issues with cracking of previous truck aprons, and so we have increased that depth. The next change we have is rolled curb. Rolled curb is replacing 1'6" curb. That has sometimes been used on roundabouts, but we want to promote the use of rolled curb. Here we have two rolled curb standards. We have a 3-inch rolled curb and a 2-inch rolled curb. The 3-inch is standard, and the 2-inch is used whenever you have a high volume of low boys. The benefits of this rolled curb is it provides a better, smoother transition from the circulatory roadway to the truck apron. Now, as you may have noticed, the faces of those rolled curbs were 9 inches and 10 inches, which is higher than the standard 7-inch face of our curbs, and so we've had to make some changes to our pavement schedules. The first change we've made is those first layers, the orange, yellow, and red. That is going to be 3 layers of surface, intermediate, and then base, and that's going to be 3 inches each to sum up to 9 inches. That is going to match up to the face of those two curbs. The other change we have made is that layer of base course on the bottom. The way this typical section is set up is that there's a continuous subgrade line under the entire section to make paving and grading easier. Now, as you may have guessed, we made changes to all of our other curbs, so here are our changes to our 2'6" curb and gutter. So as you can see, they match up to the 3-inch rolled curb as well as the 2-inch rolled curb. We have the 9-inch face for the 3-inch curb and the 10-inch face for the 2-inch curb. So we don't want to see people running these over the entire length of a long corridor. You should limit these to just the roundabout. When I say these, I'm talking about the modified curbs as well as the pavement schedule. As far as where you make that transition, that's going to be something you're going to have to coordinate with the division and construction on, and a good time to do that is going to be your field inspection meetings. The final typical section thing I will talk to you guys about is truck aprons. As I talked about previously in the presentation, there are pedestrian issues here. The problem is a pedestrian waiting in the sidewalk doesn't understand that a truck apron is not a sidewalk. And so if a person is waiting in that truck apron and a truck needs to use it, you have a conflict there. The easiest way to limit this conflict is to limit truck aprons as much as we can. Now I'm going to pass you guys over to Lily for a little bit more on the design.
Awesome. Thank you, Ty. Okay, so what we have learned through developing this guidance is that designing a roundabout is a bit of an art. You're constantly trying to balance the core design principles, which are controlling the speed, guiding vehicles clearly, promoting visibility, and accommodating large vehicles, and then bringing all of those elements together into one design that works well as a whole. So for example, if you increase your entry radii, it may help with your truck turning movements. However, it may also increase entering vehicles' operating speeds, which is less favorable for pedestrians. So you really have to consider the trade-offs of these design decisions. We added some new subsections to the roadway design manual to help designers better understand these fundamental design principles. And those subsections are the location and shape of a roundabout, vehicle capacity and lanes, speed control, speed consistency, and fastest paths, entry angles and vehicle path alignment, and then sight distance. And the designing for large vehicles section was given an overhaul. Some information that we felt was best covered by the NCHRP 1043 report was removed. And then we added some additional information regarding truck aprons that we got through feedback from pavement design and the divisions. And there has also been some additional design guidance added on truck-heavy roundabouts. So when you begin the design of your roundabout, sometimes your first instinct can be to leave the circle right where that existing intersection is, as you can see on the left there, to avoid any property impacts, but that is not always going to be the best option. So in some cases, actually shifting that circle, like they did on the right there, can help to improve some of these poor approach angles and ultimately improve how that intersection works. So ideally, you really want those legs to intersect the circle at as close to a perpendicular angle as possible. So you can see here that that one that was shifted to the right does meet that better perpendicular angle. So it's usually going to take some tweaking, some iteration, like Ty mentioned, to get to that right circle location, but it's something that really impacts the design, so it should be highly considered. Okay, so for roundabouts that are in higher speed facilities, you want to slow that driver down before they actually get into the roundabout so that they're able to go those slower intended speeds, 15 to 25 miles per hour, that a roundabout is intended for. Unfortunately, posted speed reductions are not effective. Your geometry must provide that speed control. If a driver feels that they are able to go higher than what your desired speed may be, they will do it. So that is why we added this figure to our guidance. So this figure was based on examples from Wisconsin and Florida, as well as the AASHTO Method 2 super elevation tables. So something else to keep in mind while we're discussing the approach design is to ensure that your splitter islands are not too long and too wide. So they need to be able to provide that speed control and accommodate pedestrians. However, minimizing them can help to reduce your cost and your footprint. So definitely another very important design consideration. So now let's go through an example with this high-speed approach figure. So we're going to pretend that that facility going into the figure is set at a design speed of 50 miles per hour. And then I'm going to go through an example where for curve 1, I'm going to go with the values from the table and select 1,050 feet. And then after the 100-foot minimum tangent, I'm going to select 425 feet for that second curve, and then a 50-foot minimum tangent and 100 feet. So the point you can see here is that over time, those radii are progressively getting smaller, which in turn is reducing that driver's speed, which is our goal. So this methodology was included as a best practice. These are recommended values, and if your project and your conditions dictate that you use something else, that is okay. This is also a tangent approach, so if you have a curved approach or other project conditions, that may also cause these values to vary. So this next slide illustrates a roundabout natural path, which is a term you may or may not have heard before. So ultimately what it is it's really just the path that the driver is going to be traveling throughout the roundabout based on how that intersection is actually laid out. So this is critical because it's not just what the roundabout looks like on a plan set. That's going to be your real operating movements. And it is helpful to lay out all of your vehicle swept path movements when you're doing the design of this roundabout. And that's so that you can really envision yourself in the driver's seat and get that perspective. And then from there, you can begin adjusting things such as the entry, the splitter islands, and the central islands to improve your tracking. So this is particularly important for 2x1 roundabouts, as shown here, as the driver will need additional time to select the correct lane choice. And so speaking of 2x1 roundabouts, here is a figure that was added to the Roadway design manual to help designers visualize the concept of spiraling within a 2x1 roundabout. And in simple terms, what that really means is that the vehicle path is going to be shifting towards the outside so that drivers are going to already be there when it's time to exit the roundabout. So it really just helps to avoid conflict if these vehicles are changing lanes where it would not be desirable to be. So roundabouts have 4 different types of stopping sight distance checks to make sure that drivers are able to see what they need to at different points in the roundabout and stop if necessary. The NCHRP exhibits 912 through 916, which you can see here, dictate the limits of where that stopping sight distance checks should be calculated. And these 4 different types of stopping sight distance are going to be for the approach, at right turn bypass lanes, pedestrian crossings, and for the circulatory roadway. And so we added references to these exhibits and the sections to bring some attention to them so that designers are able to quickly reference them when they're calculating this. And so now let's talk about intersection sight distance checks, which are all covered in this one figure here, Exhibit 917 of the NCHRP report. And so intersection sight distance needs to be calculated at the yield line as well as 50 feet before so that the driver is not seeing circulating traffic at the last second. So we added a reference to this exhibit as well, and there's also some associated figures that the designer can reference. So that will be available in our guidance to quickly reference. So unlike so roundabouts can have a bypass lane with yield or merge geometry, as shown in this figure that is now in the Roadway design manual. So the layout should match the condition that you want to design, or you want drivers to respond to, because that distinction is not always obvious in design. So if you want that bypass lane to function as a yield, then it needs to have the same sightline considerations as a regular intersection, which is that the driver should easily be able to look to the left, as well as tell when there is an acceptable gap for them to enter in. And then on the other hand, if you want that bypass lane to act as a merge, it's critical that there is enough side-by-side parallel lane length for drivers to then merge comfortably. So unlike a yield or merge condition, where that driver may be slowing way down or entering the roundabout from a stop, there are going to be cars that are entering in freely. And so they can carry much more speed if the geometry will allow them to. So as Ty mentioned earlier, a fastest path is basically the calculated fastest possible operating speed that the driver would be able to go. So it is critical, A, to make sure that they are not too high, and B, that they are also consistent among each other, which is another critical aspect, as you don't want that roundabout to be operationally unbalanced. And so in our NCDOT guidance, we pointed designers to this figure right here, as well as some additional sections in the NCHRP report that get a lot more in depth when it comes to calculating out those values. So here's a location where delineators had to be added because the curbing was not providing sufficient deflection and cars were traveling too fast through this movement. So this is why fastest path is critical, and if done during the design, these kind of things can be caught earlier on and then hopefully solved by geometry instead of mitigation. So the roundabout drainage guidance was updated to be in line with the NCDOT hydraulic guidance. Since roundabouts are lower speed environments, spread and hydroplaning are not going to be as big of a concern. So the drainage still needs to work. However, you do not want to over-design it either. A big point in the guidance is to keep that drainage structure outside of the vehicle path, especially on the inside of a roundabout. The better place for inlets is going to be usually along the outside curb of the approach legs before drivers reach the yield line. So this is a good place for coordination. If you're a roadway designer and you do your geometry, and then you get your drainage back from hydro, and then you see a box in the middle of the travelway, that gives you the opportunity to kind of discuss with the hydro engineer. And this does not mean anything was automatically wrong, or sometimes it just can't be avoided, right? But you can start those conversations and you can know that it's not ideal and that maybe that roadway geometry can be adjusted in order to get that box out of the road. So this is standard drawing 81502, subsurface drain for installation in grass medians and roundabouts, which was added to the 2024 standard drawings. So this is used anytime that you have drainage on a roundabout with a grass central island. And the main benefit here is to keep that center draining and basically not turn into a big muddy maintenance problem. So usually an interior truck apron is sufficient to accommodate trucks in a roundabout, but in higher truck locations that we mentioned earlier, like an interchange with a nearby truck stop, exterior truck aprons may also be needed. So this is something designers are running into a little bit more often as interchange roundabouts become more common. So truck aprons and geometry adjustments help to make the room for large vehicles while still keeping the roundabout operating as intended. So it is important that you make sure that you're designing specifically for whatever large vehicle is the design vehicle on your project, as they're all different, they all have different swept paths, and they have different small design considerations that all need to be factored in. And back to the topic of exterior truck aprons, like Ty said earlier, you want to be very intentional about where you're placing them, because placing too much exterior truck apron can be confused with a sidewalk. So it's always worth checking whether moving that roundabout circle, as mentioned before, can reduce where that apron is needed. So then there are also roundabouts like this fun one that we have shown here that are a little bit more of a creative option to help accommodate those trucks. So again, as we mentioned, it is an art. There are plenty of right answers, but just well thought of and making sure that everything is intentional and keeps the roundabout operating as a whole. So the Roadway Design Manual is a living document that is updated typically every May and November, and in this case, February. So this was our first enhanced NCDOT roundabout guidance. And more updates, particularly to the roundabout guidance, are expected in May. So if y'all have feedback, lessons learned, or just experiences with roundabouts, please reach out to us and discuss this. We want to hear from you guys, the industry, and really that would be helpful for us. So we will be reviewing all input that gets submitted to us and then that input will be considered for future updates to the design manual. So just a reminder to everybody here, and this is roundabout and any comments in general, you would want to submit these through the contact form on the Roadway Design Manual website shown here. That's what we got.
Perfect. Oh, I got it.
You got it.
I got it. All right. Good afternoon, everyone. My name's Ken Thornwell. I'm the State Work Zone Traffic Control Engineer with NCDOT. I'm going to spend just a few minutes this afternoon talking about roundabouts and the phasing challenges that we have during construction. Talk a little bit about signing and marking in those temporary conditions. And then I'm going to change gears. I'm going to talk a little bit about positive protection. I'm going to focus on portable concrete barrier, but I'm also going to touch on some changes to the Code of Federal Regulations that were passed last year. And then I'm going to wrap it up with some information on some crash cushions. So I always put this slide in here. This means if you see a product that your company manufactures, it doesn't mean I like you any more or less. It just means that you're the picture that I have. So anyway, so when it comes to roundabout construction, when we talk about roundabout traffic control, keeping the traffic moving is the name of the game. I'll preface that with, if we have the opportunity to close the roads and build the roundabout away from traffic, absolutely, let's do it. We can get them knocked out fairly quickly. Unfortunately, most of the time that is not the case. We don't have the ability to close the roads. So when that happens, we have to work really hard in traffic control in order to keep that traffic moving. One of the biggest challenges that we have in traffic control is that when we change an existing pattern to a new pattern, whether that's a roundabout, whether that's a diverging diamond, channelization, proper signing, proper markings is very important because we are changing the daily habits of folks that may have been using this intersection for decades. Some of the other challenges that we have are alignments, because when we go to construct something like a roundabout, a lot of times we might have to shift traffic several times in order to get all the pieces of that roundabout constructed. Super elevations become a challenge for us. It seems the super elevation might be one direction existing, and then it's got to change to the other direction in final completion. So at some point during wedging, we may end up with no super elevation or a flat area. So it becomes challenging for our contractors to maintain some of that positive drainage in those interim layers. The center islands, getting those constructed can be a challenge. The splitter islands, Lily and Ty were talking about slowing traffic down before they come into the roundabout. But if those islands aren't constructed yet, we're trying to do it with drums. We're trying to do it with cones. And the problem is that those cones and drums don't do well when those trucks try to come through. Pedestrians, I'll back up. Pedestrians, you saw my little guy running around on the screen here. Even though we don't have any marked crosswalks here, we do have sidewalks and curb ramps on basically every single side of this intersection. Federal law requires us to maintain pedestrian movements throughout all phases of construction. So just another thing for our traffic control designers to keep in mind. And then as well as the interim changes when it comes to, like I said, the signs, markings, and signals. So here, this 5-sided intersection that is currently signalized, at some point in time when we go to construction, that signal is now in the way. So we need places to put temporary poles, guy wires, span wires, and all the equipment needed to maintain that traffic during construction. So this is the public hearing map for that intersection. I look at this picture, and as much as I love colors, that thing makes my head hurt. So the challenge is where do we start? What do we build first? Where are we going to put our temporary signal poles? How are we going to maintain drainage? Where are we putting the pedestrians? How are we keeping bicycles moving? Right, so those are all the things that have to be taken into consideration. So this is one of the traffic control plan sheets, and I just wanted to highlight in green here, you can just see the green boxes just represent the work that we have to do to keep the pedestrians moving, right? Like, it sounds simple, right? Keep the sidewalk open, but as you can see on this screen here, we have pedestrian barricades, we have temporary curb ramps, temporary crosswalks, temporary signs, temporary sidewalks that all have to be constructed, to keep those movements. And then as a bonus, I highlighted in purple some of the temporary drainage that the designer put into the plan set. You know, we've got pipes that are going to be installed and then plugged, or we've got places where we're taking the new drainage and connecting it to the old drainage in order to keep those pipes flowing. I put this one in here. Here's a nice easy one. As Lily and Ty were talking about, The center of that circle is outside of the intersection, so it looks like we can build most of it offline. The Y lines don't look too complicated. No pedestrians. It's all two-lane roads, minor super elevation changes. Everything looks glorious. And then we put up the profile, and it is 3 feet in the air for 500 feet on one of the Y lines. A little bit of a challenge. So it was determined that there's no way to build that under traffic. We don't like to wedge 3 feet. It's very expensive. It is very interesting when we come back later and try to work on a road and there's 4 feet of pavement in there. So we ended up having to go with a full closure for this route. Not a major deal, but the problem is that we need to identify these closures earlier in the plans. We need to know these really at that 2TM2 level of plan design, because there's a lot of coordination that needs to happen. Like I said at the beginning, I'm all about closing down some roads. Let's close it down and build it. But when we do that, we need to analyze that detour route. Like, what is the pavement structure on the detour? Are we sending traffic on any weight-restricted bridges, low-clearance bridges, railroad crossings? Are we going to increase turning movements at unsignalized intersections, or do we have to build temporary turn lanes at an off-site intersection to handle that traffic? What kind of signal timing changes do we need to do along the detour? And then coordinating with our stakeholders. Have we told the school system? Does the school system have the ability to change bus routes? What about fire and EMS? What about just the local government, the garbage route, all of those things? Once we get all that worked out, then we move into the more public communications, right? We got to let the public know ahead of time. Daycare, right? I always tell my staff, the afternoon rush hour is very important, because if you are not at daycare at 6 o'clock, it is like $25 a minute, right? So if we close this road and we didn't give public advance notice, and now they got to go a 10-minute detour, that is real money to somebody who is late picking up a kid from daycare. Yeah. A little bit more on roundabout construction. Sometimes we're working on multiple legs of the roundabout at the same time. Sometimes we can build half the circle. Sometimes we can't. Sometimes we can put traffic on one direction going around the circle. Sometimes we have to maintain a signalized intersection, but with reduced lanes. So we have an example here where that's exactly what we had to do. We had to take 2 through lanes and reduce it down to 1 during construction. The day we did that, we caused 2 miles of queuing, and every single day after that, we continued to have 2 miles of queuing. If we knew that going into the design, there are things that we can do, right? We can look at maybe some temporary widening. We can look at maybe going with narrower lanes. We can maybe look at putting intermediate contract times to encourage the contractor to limit the duration of this phase. So just a lot of those things that need to be considered when we go into constructing roundabouts. I mentioned signings and markings. What we hear a lot of times is, oh, well, we don't need a temporary signing plan because we're just going to install the permanent signs. Well, the problem is that you don't have islands yet a lot of times. We've already gone and moved that pattern into that circulating movement, but we don't have splitter islands. We might not have a central island. And then, like I mentioned, this is a new pattern to folks who, especially, this one's in the western part of the state. They may not have ever seen a roundabout before. So it's very important that we get the signing installed, especially the regulatory signing, yield signs, one-way signs, stop signs, whatever the case may be for the condition. And then same goes for the pavement markings, making sure that we're using the proper fishhook arrows and all that kind of stuff. We want to see that stuff on the temporary traffic control plan, because the permanent signing contractor is not coming out in phase 2 or 3 of the project, right? They are coming out at the very end to install all the permanent signs at one time. So if our temporary traffic control contractor needs to order some of these fishhook arrow signs, it needs to be in the plan so that way they know to fabricate it and get them delivered to the project. So that's all I have on roundabouts. I'm going to shift over into positive protection now. Positive protection, pretty straightforward. Basically, any device that redirects vehicles and is crash-worthy. You know, it keeps our workers safe, it keeps our motorists safe. A couple of definitions here, and I'll go over this a little bit more in a few minutes, but North Carolina DOT, we consider high anticipated operating speed at 45 miles per hour. That's basically the difference between test level 2 and 3. That is also the point at which 50% of pedestrians are not likely to survive if they get struck. And then the last one there, no means of escape. Basically, we're, as a department, we have to formally define what no means of escape is. So we made a fairly generic phrase there. Basically, if your workers do not have an unimpeded way to escape the path of an errant vehicle, then that means that they have no means of escape. So there's a lot of information out there. We have some barrier design guidelines, some positive protection analysis stuff that can help designers get through that design analysis. But let's see, I'm gonna skip ahead a few because my presentation this morning had the slides in a little bit of a different order. But a lot of what's driving some of these new slides here is a change to the Code of Federal Regulations, which went into effect last year, and it's a phased implementation. Basically, the highlighted things here, as I mentioned, we are required to define high anticipated operating speed, which is 45 in North Carolina. No means of escape, which means workers don't have a way to run away. And then we also have to formally identify engineering study. But this is where this Code of Federal Regulations, I think it caused a lot of folks to get nervous because it says three things. It says that if the project has federal aid, and if there's high anticipating operating speeds, and if the workers have no means of escape, then you shall use positive protection to protect those workers. If, for whatever reason, you cannot, then you shall do an engineering study to eliminate the positive protection. All right. So what does all of that mean? Does it mean we're going to have positive protection everywhere? No. What we anticipate is that it will not change our day-to-day stuff. There are no projects in the state that I'm aware of that this new requirement changes what we have been doing. What it does change is those 2 or 3 projects a year where we might not have positive protection, rather than just sealing a plan sheet without having it. Now we just have to do a little bit more documentation. And that is where this positive protection analysis and engineering study come in. It is a little bit of a lengthy document. It's like 8 pages of check boxes and some calculations and stuff. We're going to be doing some training on that later this spring and summer. But again, like I mentioned, it will not apply to 99.9% of projects, right? As long as we are providing the positive protection, then we do not need to do that engineering study. So what I'm going to do is I'm going to back up a little bit then to where we were. Positive protection. So obviously we're going to use it as much as we need to, right? The benefit is that positive protection. If somebody strikes it, it becomes a somewhat of a controlled collision. It reduces the severity of crashes, but we still want to manage the risks. Positive protection increases crash frequency. When we put 70 miles of concrete barrier on I-95, crash numbers are going to go up. Right now, those crashes are less severe than if they run off into a ditch or an open grade or a culvert that's under construction, but the crash frequency is going to increase. It also increases the response time to crashes. It also increases the probability of secondary crashes. It also causes drainage and sight distance concerns, potential issues with oversized loads, construction access for our contractors, and then the tremendous amount of worker exposure required to install and remove it, especially if it's anchored concrete barrier, right? If it's anchored concrete barrier, that means that we actually have to have guys standing on the side of the road, drilling holes into the pavement and dropping pins in this barrier for miles, right? And then when it comes time to pick it up, they got to go out there and do it again. They got to go pick all those pins out. So couple couple of things I like to just remind folks that every single time we use positive protection, whether it's portable concrete barrier, whether it's water-filled barrier, guardrail, these things, they have the ability to injure people, and that's why we do require all barrier installations to be signed and sealed. But ultimately, the ultimate goal is to just minimize the use, right? Get the work away from the traffic or get the traffic away from the work, right? If we can close it and build it away from traffic, that's what we want to do. All right, so getting into the types of positive protection, concrete barrier, right? That's tried and true. Everybody knows it. We use it everywhere. But the big thing in here, right in the middle there, NCHRP 350 versus MASH 16. That basically means that in 2021 timeframe, we switched to MASH 16 barrier, but contractors can still use their old barrier. Means a couple of things for designers. One, we have to design as if it's MASH 16. It's a little bit stricter design criteria. Because the problem is we don't know what the contractor is going to show up with, right? It's one pay item. They can bring either one. They might bring 350 for the left side of the road and MASH for the right side of the road, and that's perfectly fine. They're allowed to do that because if we just required MASH, there's not enough on the planet right now to meet our needs, right? So we have to, right, they can only manufacture a couple hundred feet of this stuff a day, so we have to let them grandfather in that old barrier. And I know this is really hard to see. I'm going to zoom it in a second. But one of the major, this one doesn't have it. It doesn't have my zoomed in one. But anyway, I'll just read it. One of the main differences here is that when we go to anchor that new MASH 16 barrier, this is the detail for the new MASH 16 anchoring. We cannot anchor both sides of that concrete barrier, right? The anchors have to be on the traffic side of the barrier, and they cannot be on both sides. So that means if we run concrete barrier down the middle of two lanes of opposing traffic, there is not an approved method to anchor that barrier. All right, so that is going to play a role in the widths of some of our travel lanes when we go to use it in that situation. Another change, the MASH 16 barrier, it has to be anchored on the ends. So when you come off of a temporary crash cushion, those first few pieces of concrete barrier need to be anchored into the pavement. That became a little bit of an issue because it's how do you pay for it, right? If we're not using any anchored barrier anywhere on the project, how do we pay the contractor to go out there and drill these holes, right? It's like, well, the easy answer is just give them a pay item for a transition. Well, then the problem is that if they use the 350 barrier, the 350 barrier does not need to be anchored on the ends, right? So basically what we did is we developed a standard special provision that gets put into contracts. When we are transitioning from a crash cushion to unanchored barrier, that transition is incidental. Contractor does not get paid. If we are transitioning between anchored barrier and unanchored barrier, for example, you have unanchored barrier running down the shoulder and you're getting ready to go underneath a bridge or over a bridge and you need to anchor it for that 100 feet, we need to transition into that and then transition back out of it. And what this special provision is going to do is it's going to say that those transitions count as anchored length. So that way the contractor will get paid for them, right? And that was somewhat negotiated with the AGC and CAPA, so that way it kind of becomes a wash for them. Another quick thing on concrete barrier, we a lot of times see where a guardrail gets cut. A contractor likes to tuck the concrete barrier behind the guardrail. It's okay. It's not ideal. What we prefer to see is the guardrail tied to the barrier. But if that can't be done for whatever reason, we have two options. We can either put a crash cushion on the end of the concrete barrier, put it in front of the guardrail like the top half of this picture, or we can tuck the barrier behind the guardrail, but it will require temporary pavement, and it's going to require a anchored end unit on the end of that guardrail, so the CAT 350 end units. All right, temporary crash cushions. If anybody is checking their emails today, you may have gotten an email from me this morning. Effective with May turn-in, so that is what, like 45 days from now. we now have to call out when gating or non-gating units are used. So just real quick, a gating crash cushion, a lot of times, most of them, they're water-filled. So you see a big bright yellow water-filled crash cushion on the end of a concrete barrier. That is a gating unit. That means if a vehicle strikes that on an angle, there's a chance that the vehicle may penetrate through it and end up behind the barrier. That is okay. That is the way it's designed. That's the way it's intended. But if you have a situation where that's not going to work, like in the picture here where that crash cushion is right in front of some temporary shoring, the barrier can't be extended because of sight distance or intersection concerns, then we would require a non-gating crash cushion. And all that means is that if that crash cushion gets hit on an angle, instead of the vehicle penetrating it, it'll redirect that vehicle back out into the roadway. So the big thing, like I said, starting in May, if you do not specify gating or non-gating, that allows the contractor to use whatever they want. If your design requires the use of a non-gating terminal, then you just need to call that out on the plans and use the appropriate symbology. Just two more real quick. Water-filled barrier. Water-filled barrier. Every time I see it on a plan sheet, every time any of my staff see it on the plan sheet, they think it's like winning the golden ticket for Willy Wonka. They immediately run and show it to me on my desk because the note at the bottom really says it. If you, as a designer, can make water-filled barrier work, then you can make concrete barrier work. Because the problem with water-filled barrier that most people don't realize is the minimum length is longer than concrete barrier. The deflection is 3 times higher than concrete barrier. It's the end units are almost always gating. So, you know, the message that we try to send is yes, it has applications. It is more applicable as a channelizing device. They work great actually when we go to change things like diverging diamonds. You know, when those curves are not in yet, right? We can get nice solid channelization. But as far as a redirective barrier, it's not 99% of the time, it's not the right answer. Likewise, the last one that we hear a lot about lately is steel barrier. I get asked a lot of times, are we ever going to standardize steel barrier, put it in specs or standard drawings? The answer to that is probably not. The reason is because all the designs are proprietary and they're all different. Right? Every single manufacturer of these products has a different set of rules on how to install it. They have different widths, different deflections, so there's not really any way for us to standardize a design for that. Contractors love it. You can fit several hundred feet on one truck. The salesmen say that you can install it much faster. It seems to go much slower every time I've seen it. But it is much lighter. The shipping costs are tremendously reduced. So if a contractor wants to use it, you know, we will look at it every single time, and I'd say 7 out of 10 times it's okay. We will allow that swap. But unfortunately, it is not a one-for-one swap, so we do have to look at it every single time. That's all that I have. Appreciate the time this afternoon, and I guess we'll open it up to questions. Just.
Just a couple questions. First of all, great presentation.
Thank you.
Great presentation, everybody. Just loved every second of it. My first question is, yeah, I think so. My first question is there a recommended maximum traffic volume for each approved roundabout type? Is it like
There is.
there is?
No, I think, and I'm going to look back to Joe back there. I see him back there. I think it's 25,000 all approach vehicles from all approaches for a single lane. Mm-hmm. And right now a mini is 18,000 okay. All approach, all, you know, adding all the legs approaching the roundabout.
Okay. Is there any opposition to truck aprons at sidewalks or at the roundabout being paint striped for pedestrian awareness and safety? So is there any reason why we would not be allowed? to investigate paint striping and apron in one way or another.
You mean instead of the truck apron? Or
No,
instead
no,
of,
no. In addition to the
In
truck
addition
apron,
to.
because I know when it gets close to the sidewalk, pedestrians don't always know, as it was mentioned, as Lily mentioned, don't always know that it's not actually sidewalk. You know,
Yeah, and we haven't seen a lot of them, but there are a few installations. I think that's a coordination effort with pavement marking, with roadway, with, you know, if they're,
case by case.
it is case by case
Yeah.
right now. I mean, we're pretty early in trying to get our specific guidance out there, and that's what
Yeah.
we'll be asking folks to help us, you know, as we learn more about operations and the craft of roundabout design.
I'm glad about it. You don't have to guess at it as much anymore. So I think that'll be great.
Hope not.
Is there Ken, is there guidance for determining if a road closure and or off-site detour is warranted for roundabouts, or otherwise anyway? Is there any guidance? Because I know in some cases, sometimes it's obvious, but sometimes not.
My approach is always, let's close it until somebody tells me no.
Okay.
If it's not the division, it's usually the town.
We do, because we do try to identify it as early as possible. Like, is there going to be an on-site detour here or an off-site detour? We try to identify it as early as possible, but I wasn't sure if there was any
Yeah, I think
knowledge related.
I think that there's a lot more opportunities to close things than we take. I think that you know, like I said, it's a lot of times the cities, the towns, the municipalities that resist that. Part of me says easy for them to say, they're not the ones out here building it, and the first time they need to replace a water line, they're going to close the road. I think it's just, you know, trying to anticipate some of their concerns ahead of time. Like if there's a school nearby, you know, it's like we need to already have a plan for what they're going to do with buses.
Yeah.
Right? We need to already know that the alternate route is going to work before we go to them and say, oh, we're going to close this road down.
I guess more specifically, if your elevation change exceeds a certain amount, or if you're horizontal.
Well, so part of it's elevation change, but then part of it is the worker exposure, and then just even the cost. At last check, flagger days are $650 per flagger per day, and if you're building a roundabout, you probably need 4 of them. So you're at $2,500 a day just in traffic flagging, right? And that's whether they're using humans or AFADs, the automatic flaggers. We pay them all the same. So
The recommendation more of having that session with you all.
yeah, I mean, like I said, my recommendation is if there is any opportunity to close it, even if it's not for 100% of the construction, if it's for 15 days or 2 weeks, you know, 3 weeks, 4 weeks, whatever the municipality or whoever is opposing that will, as much as they will tolerate, if we can get as much of it built as we can, it's just better product, you know, better productivity. We'll get lower prices from the contractors, right? Just the benefits are enormous. It's just, you know, we got to just mitigate the impact to the public.
You mentioned, I'm sorry.
No, go ahead.
You mentioned wanting to have that identified at or before 2TM2.
Ideally, yeah.
So would that be something that could be something, I guess, a task for
Well,
2TM2 to have those?
So the 2TM2 submittal, they're supposed to have basically a traffic staging concept, you know, actually, you know, even a little more than that. So the TMP designers should have already looked into that. Well, we don't, yeah, 2TM2 is our first.
That's right.
2TM1 is congestion.
So the one TM.
In traffic control, our first PDN task is 2TM2.
2TM2. So will we need to identify that with congestion, or?
I mean,
You have to do
It
the
might
user
be-
cost,
might be-
right?
yeah.
I mean, the user cost of any detour has to be evaluated.
yeah, and detour user costs are fairly easy for us to run. So if somebody were to call us up and ask what a user cost would look like on a detour, that's something we can knock out very quickly.
But unlike a bridge job where we know we're going to have to close the road, I think part of the thing is, we have yet to develop a roundabout typical section that shows resurface and wedging underneath it, because they're mostly on new location usually, so we One thing we put in the manual is to try and pay attention to minimizing the wedging where you can. I mean, it's not a resurfacing design necessarily, but, you know, to get it down to where it's constructible without detouring traffic, as soon as that's known, I guess that needs to be coordinated with the traffic management engineer once you set the profiles.
It sounds like once we have our alignment set, that might be some discussion that we may have. Design the project, kind of talk through that, and then have a conversation, see what comes up.
Yeah, as early as possible. So I think we are at time. I'm happy to answer any more questions if anybody has any, but I'm not going to get offended if anyone gets up and runs for the doors either.
Yeah, we're glad to stick around if somebody wants to ask some more questions. It is an art. It is an art. It is a craft.
Somebody came up to me yesterday and was like, "Roundabout is like an
Thank you,
art."
sir.
And I was like, "You just said that sentence to me." Like, no. Hey, thank you. Yeah. Good to see you.
Oh, thank you. Appreciate it. Appreciate it. Is it good? Okay. Yeah. Yeah. Thanks, Bert.
Oh, well, hang on. Thursday night.